Hi, this is Mary Tracy. Northern California Neurotherapy is my clinical practice, and qEEGstrategies.com is my educational entity online. And you are listening to the NeuroNoodle Network podcast.
Welcome to NeuroNoodle's Neurofeedback and Neuropsychology podcast, featuring our neuropsychologist, Dr. Laura Jansen's tech whiz Santiago brand, neurofeedback legend, Jay Gunkelman. Our goal is to provide information and promote options for better mental health. This is an all-star cast, more than happy to share their knowledge with you. My name is Pete, and today we have a very special guest, Mary Tracy, Director at Northern California Neurotherapy. She's also the founder of NeuroTraining Strategies and qEEG course wizard at Sten's University /Mind Media. Maybe I got some of that right. But before we get to Mary, we got some Patreon love to dish out. Well, of course, Mary Tracy's NeuroTraining Strategies offers a higher standard of EEG, qEEG education to EEG clinicians, technicians, and neurofeedback practitioners with convenient online BCIA and qEEG certified didactic courses. And if you didn't know from the last show, the 6th annual Super Brain Summit is April 8th at Bradley University, featuring Dr. Bruce Wexler. He's a psychiatrist at Yale Medical School. He will discuss neurotherapeutics. How can we regulate the brain with computers? Register now at bradley.edu/superbrainsummit. Please give us 5 stars on Apple Podcasts. Really helps get the word out. If they can't hear us, we can't help them. Okay, couple housekeeping items here. Dr. Skip, he's going to take a break from the show for a little bit. It's just like all of our hosts on the show. They come in whenever they want. They leave whenever they want. You know, we'll take what we can get. But for the month of April, Seaburn Fisher will be joining us for every show in the month of April. That is correct.
Wow.
Mental Health Awareness Month is May, and she's going to come on and give us a little kickstart. And if we all get along, you know, we might continue it. Who knows? That's how we started with Jay, right, Jay?
Am I on this show?
So I'm excited. From where we started with this show to not even have any video to where we're at today, it's awesome. And then Jay, we lost someone dear to you.
One of my main mentors, Dr. Meyer, Proler, unfortunately passed without any distress or anything, just kind of a sudden passing in his late 80s. So it's not totally unexpected. It's not easy to become somebody in your late 80s. But, you know, he's the only doctor I know for sure that's read more EEGs than I have. And that's not easy. But he's been at it even when I stepped away in the late. Dr. Proler, Dr. Proler's obviously going to be missed. It's hard to replace somebody with that kind of experience. And he was a very gentle hand. As a tech, it's easy to have a doctor who's doesn't really honor a tech. And Meyer was always very gracious with his education. And in his later years, I would actually go to Houston. I worked for 2 years commuting to Houston for 2 weeks out of the month. I got full-time pay for two weeks out of the month of work. I just was paid for the month. And I actually took care of the lab and wrote draft reports. And when he wasn't there, the neurologists were told, Jay will draft a report. If you agree with him, sign it. If you don't agree with him, chat with him. If you can come to an agreement, sign the report. If you can't come to an agreement, set it aside. I'll look at it when I'm back. So that's a lot of pressure for a tech, but he always found doctors that were gracious enough to end up suffering this fool. And it was a tremendous education having 100 or more EEGs a day come through. When I would draft something, I draft reports when he was the reader as well. If he read the EEG and agreed with the report, he would sign it. If we didn't, he would have me come in and we would look at it together. So this was a gigantic leg up for learning about EEG, and he was gracious enough to help me along over all those many years. So, and that's not possible to repeat. We had other doctors come through the lab over the years, and John Hughes, the Gibbs, the Fred and Erna Gibbs, Charlie Yeager, who he always introduced himself as, "I'm Charlie Yeager, not the pilot." But he read in the lab, and he was still in his 80s when he retired fully. He invited me to his 100th birthday party, and I paused for a little bit and I said, "Okay, on the condition that you'll accept an invitation to mine." Obviously, he's passed, but he was brilliant, MD, PhD, and he started the Mayo Clinic in the 1930s, their EEG lab, after translating Berger. So I've had some fabulous mentors over the years, and as I say, John Hughes is the last one still around. So
Dr. Ron Swatzina this morning at the AAPB meeting introduced his talk by giving credit to Meyer Proler for having kickstarted Ron's interest in the integration of psychiatry and neurofeedback, and especially pharmaco-EEG. He said he just learned so much from him. I guess he was a mentor to many, huh?
Yeah, he was generous with his time. Anybody who was interested basically was helped. And as I say, it's impossible to replace that man. So
pour one out for him. Good man, good peeps.
Yeah,
Jay.
And we all go at some time. I'm glad to see that he didn't have any suffering or distress. He didn't deserve anything like that, and I hope his family does well.
Hey, thoughts out to their family. All right, we got this model here called Mary Tracy. She took a break from one of her photo shoots, and Mary, what? First things first. Welcome to the show, Mary Tracy.
Thank you.
What the heck is going on at Mind Media?
Mind Media has, in January 1st, they purchased Sten's Biofeedback Corporation in San Rafael, California, and they're in the process of continuing to move through the transition. It has met many obstacles because of supply chain problems and a whole host of other things, but we're getting there. It's been very, very slow and sometimes agonizing. But now Mind Media in the Netherlands will be more or less controlling stensacademy.com, which is actually the website where people go to buy the courses and buy products, as well as Mind Media USA. So they've set up two entities in the United States. So now Steve Stern used to have the Northern California market, and he was the exclusive distributor of Nexus equipment. Now Mind Media, which is the original equipment manufacturer, will be the exclusive distributor in North America.
How's Erwin doing? Erwin, you listening out there? Hope you're feeling better. He's a little under the weather. Sniffles.
He's been a little under the weather, and the war, of course, is not helping over there. Everyone's freaked out about not only their own health and safety and the possibility of the war
Didn't even
spreading,
think about that, yeah.
but I have one person who I've been mentoring for a while. She got her qEEG last year, and she said she's terrified that she's not going to be able to get insulin for her son, for her 5-year-old son, who desperately needs it to stay alive. That kind of thing, right? Plus, people are losing friends that they know, associates, colleagues in Ukraine. So it's just, it's an unthinkable tragedy.
Well, it's all relative. You think you're having a bad day, you could be over there, right?
Yep, exactly.
Hey, how's the Gunkelmentary coming along?
They're showing it Friday at AAPB, 7:30 Central Time, in their Synergy Lounge or Synergy area, which is a free to public access. You don't have to be paying to attend the meeting to attend the Synergy area. So anybody who wants to take a peek at it can go to the AAPB website and look under their Synergy Lounge, and you have to register, but there's no cost. And you get a Zoom link to be able to zoom in from wherever you might be. I'll pop up at the end. I think Mary, or are you going to be doing a little intro at the beginning?
I don't know. Michelle hasn't asked me to do an intro. I thought I may be
Okay.
coming in at the end with you, but she told me something amazing. She figured out a way to live stream it to all of the rooms in the hotel. So, you know, when you click on the hotel TV and you get all the different options, and, you know, where you can buy snacks and
Hopefully you picked the right option.
You can see the signal and the noise. I mean, what more could we ask for?
Stay away from those other movies.
Room service, and signal and noise. Huh? So
yeah.
And then you know, like a little tradition, we have Mary on the show. All right, it's just between us. The first 10 people that email Pete will get a link to check out the Gunkelman. Don't tell anyone. Did I say that right, Mary?
You did. Very good.
Okay. All right,
I knew
fantastic.
I could count on you.
You know. Okay, so now you got a deck for us to look at, Mary. What are you going to be talking about?
I'm going to be talking about the prefrontal cortex, which is occupies about a third of the brain. And it's kind of the business end of things in terms of how we manifest, how we show who we are and what we can do. And when we encounter obstacles in life, maybe we've been born with a type of ADD or ADHD, or I mean, so many things that can go wrong in the brain in young kids. We go into a failure mode, and our actions and our behaviors become apparent to others that we're not succeeding, either personally or socially or educationally. And we can actually see activity in the brain that's correlated with these things, and we can actually do neurofeedback to help restore. Maybe it's not restoring, maybe it's for the first time in a child's life or an adult's life, help them to function in more optimal ways. So it's a really interesting part of the brain. It's got a very colorful evolutionary history, and it has really strong implications for adolescence and old age. That really will help. If you know about this, it's going to help you to attend a little bit differently to some of the obstacles that adolescents and people who are going through a normal aging process encounter. My PowerPoint presentations tend to look like storybooks. I like to have fun when I'm educating, and teaching about the prefrontal cortex is so cool because it's one way that you can talk about the function of the entire brain for people who aren't really well educated about the brain. And I like to use a lot of colorful pictures, and we're going to have some fun here. Okay.
Good. And this is sort of like when you're doing your class, right? A lot of this stuff is from your class. I mean, not everything, because it'd be a total freebie, but this is like having a Mary Tracy class.
This is like having a Mary Tracy class. It's a bit stripped down because the audience is broader for NeuroNoodle than it is for people who have signed up to learn how to do qEEG analysis and neurofeedback, but we've still got some pretty heavy duty science in here.
Okay. Feed me.
Okay, feed me. So the basic function of the prefrontal cortex is the representation and execution of new forms of organized goal-directed behavior. So all of the so-called executive functions in the prefrontal cortex serve that subordinate function in one way or another. So one of the things that we know about the prefrontal cortex is that it's thought of as a personality center. It's the cortical region that makes us uniquely human. It's where we process moment-to-moment input from our surroundings. We compare that to past input, to experiences, and then we react to them. So it's, you know, we have to issue a disclaimer here because it's always dangerous to talk about a part of the brain because people begin to insinuate that that part of the brain does this, that, or the other thing. And that's not what we're talking about here. We're talking about a part of the brain that coordinates in a network function a whole bunch of input from the rest of the brain. So basically, it's what defines who we are and how we manifest behaviorally. So it's considered a perspective and predictive part of the brain. So it works as an integrator of current inputs from cortical and subcortical sources. And it's capable of feeding some signals from information that comes into the back of the brain to the front of the brain via some heavily myelinated tracts. And that information gets played out in real life, and then we learn from that. So we'll give you an example of this. So sensation and perception is known to be the receiving area for sensation and reception is in the back of the brain, the receiving end of the brain. So we have sensation, perception, and a whole host of other factors that get integrated here. And then we have the frontal cortex, specifically the prefrontal cortex, which is the business end of the brain. So what we're doing here is we're translating perception to action. There's a gentleman by the name of Joaquin Fuster, who I should have put a picture of him in here. He's more, I would consider him to be the preeminent scholar on the prefrontal cortex. And he describes something known as the perception action cycle in the human brain. So when you look at this illustration here, again, this is sensation perception in the back. Here's the front of the brain, business end of the brain. And we can see that there's a bunch of information coming from posterior association cortex to the front of the brain. We also have subcortical input from the amygdala, the hippocampus, the thalamus, the hypothalamus, and the brainstem. So we carry abstract information, cognitive information about past experience with ethical principles and values. We look at subcortical inputs from limbic structures, which might involve the insula, for example, which the anterior insula is one place where we register empathy and the theory of mind, being able to hold a representation of the other in mind and being able to associate feelings with that person. And then all of this gets driven to the prefrontal cortex so that that part of the brain can act on it and produce goal-directed behavior. So here's Fuster's perception action cycle. So we have two cones here. The past cone just shows some examples of some of the functions that might be perceived that will converge to the frontal cortex, to the prefrontal cortex, in order to help us make decisions. So these two cones of decisions meet in the present. And one's formed by these converging potential inputs from the past. And the other one is kind of a diverging decision-making option in the future. So we say that the perception action cycle is an adaptive biocybernetic interface between the brain and the environment. Again, it's perspective in nature, meaning that the cycle determines our actions in the future, and then the feedback from those actions become part of the encyclopedia of the past that then informs the future. So this is beginning to sound a little matrixy, right?
Hey, let's take a break in the action to tell you about the Super Brain Summit at Bradley University. You can check it out online at bradley.edu/superbrainsummit. It's happening this April 8th. Featured speaker will be Dr. Bruce Wexler, an international expert on digital neurotherapeutics, and he's a psychiatrist at Yale School of Medicine. Hey, visit the Brain Cave, walk through the brain using Oculus Quest. How cool. Check it out April 8th, bradley.edu/superbrainsummit.
So we have here an example of someone who's having an experience that's going to inform his future. And of course, that's a joke, right? It's a GIF, it's a joke. But when we have something like that happen, obviously you get the point. that's something that informs about how we need to do that differently the next time. I want to diverge just a little bit and talk about the evolution of the prefrontal cortex. I'm not an anthropologist. I never took a class in anthropology, but this stuff is absolutely fascinating. So compared to apes, humans have an increased number of glial cells per neuron. They've got a greater space between neurons, and they have this really elaborate astrocyte network, a glial cell network. And I refer to this as the motherboard of the brain. It's far more extensive than apes. So it's a measure of connectivity in the brain. And we see that anthropological data tends to support this finding, that this extensive network of connectivity in the human brain far surpasses that of other species, even our most closely related ones. And it really is the underlying principle and foundation of our unique human character, our intelligence, and our abilities. Here's an interesting graphic on the volume that the prefrontal cortex occupies in a cat, 3% of the total brain volume. In humans, it's 30%. And, you know, this is a disproportionately large amount of gray and white matter in the human PFC that's compared to other brain areas across species. So again, this is suggesting an impressive amount of neural machinery that's associated with the human PFC. So this is a graph showing time starting from millions of years ago up to the present. And this is our cranial capacity. And we see this inflection point here at Homo habilis. Homo habilis was the handyman, the tool user. And it used to be thought that what's happening here in terms of this exponential increase in the cranial capacity of hominids and of humans in particular is that it was our ability to use tools that was helping us to advance in this area in an evolutionary way. But right now, the current theory is that all of this evidence points to the fact that the PFC, the prefrontal cortex, increased disproportionately in the human being as a result of increases in social complexity. So I had mentioned already theory of mind, the ability to think about your mental states, your own and those of others, to control our emotions in the interest of social well-being. These are all highly evolved in the prefrontal cortex. So this feature encompasses our ability to both model and to teach others about our mental states, including emotions, desires, belief, and knowledge. So I'm going to look at the Neanderthals for just a second. Here's some Neanderthal fun facts. Recently, anthropologists have been doing these amazing reconstructions from skeletal remains. Here's a Neanderthal man, Clean. He comes from an area around the Netherlands, what's now the Netherlands, and Shakira. And about 100,000 years ago, there were 6 distinct species of humans roaming the earth. They apparently began interbreeding, and they actually bred themselves into extinction. They were so fond of one another. Now, I think because humans were evolving in Africa, in Northern Europe, in Siberia, the Denisovans were evolving in Siberia, the Neanderthals in Northern Europe. I think they like to take vacations because, man, they traveled far and wide. And we have found remains of different human species in the same cave. So Shakira and Crean were probably having some pretty good times together as they managed to participate in breeding themselves into extinction so that we have only one species of human being now on the planet. And you might ask, how come the great apes, you know, the gorillas, the chimpanzees, and the orangutans haven't done that? Turns out they can't interbreed. So what does the PFC do for us? What kinds of things does it regulate? First of all, executive functions, working memory, rule learning, planning, attention, decision-making, all of these things that we're used to looking at when we do an assessment on someone who might have attention deficit hyperactivity disorder. They might report problems in many or sometimes all of these areas. And again, when we see a failure mode in the EEG that's associated with ADHD, even if we don't know the history, we can pretty much be sure that we're going to see some symptom presentations like that. Depressive symptoms are associated with the dorsolateral prefrontal cortex, that can show a loss of initiative, motivation, reduced verbal output, behavioral slowness. We can also see frontal midline symptoms that are associated with obsessive compulsive disorder, maybe oppositional defiant disorder, and affective regulation. The inhibitory control, as we're going to see in a few slides, is really important in terms of regulating impulses, whether it's coming from an emotional route, we're angry at somebody, we're pissed off, we're going to throw a temper tantrum, and we just can't stop ourselves. Or maybe we have a problem with eating or drinking or any kind of obsessive behavior. The ventromedial regions of the prefrontal cortex exercise regulation and control over these impulsive urges. The right, this should say prefrontal, PFC, typo there, region coordinates inhibitory control of emotional content. And then we have expressions of morality, which is, central, midline, inferior orbital areas of the brain are directly connected to the limbic system. And Jay will be able to tell you about this because Jay has a great story about the limbic system banditos and how they tend to take over the otherwise rational functions of the prefrontal cortex. So these expressions of morality regulate empathy, socially accommodative behaviors. Again, we see that theory of mind phrase. There's a couple forms of attention that we don't really learn when we're taking Psych 1 or even neurocognitive psychology courses. There's inclusionary and exclusionary, and these two forms of attention operate simultaneously if the brain, the prefrontal cortex, is firing on all cylinders. So the inclusionary attention is when we are directing our attention to and focusing on a particular item of our experience. And this is mostly the realm of the dorsolateral prefrontal cortex. The exclusionary attention is really quite a remarkable phenomenon in the brain. If you think about all of the bombardment of information from the external environment, not to mention interoceptive things that we're feeling, body feelings, emotional things that are happening, cognitive things that are happening, so many sources of distraction. And the ventromedial prefrontal cortex helps us to filter all of those out so that we can attend to a task and accomplish something. So this is an example of inclusionary intention. And this is the dog who's being thrown a treat. You can see how disappointed he is when he misses it. And we don't, I'm not going to say that I've recorded an EEG on a dog and that he had any problems at all in his dorsolateral prefrontal cortex. But I think this is a good example of what we mean by an attentional focus on something that has a high reward value. A lot of the prefrontal cortex evolved in terms of survival, in terms of regulating goal-directed behaviors towards survival. And for dogs, eating is a big one. Here's another doggy who's giving us an example of exclusionary attention. And this is more the ventromedial prefrontal cortex. This is a dog who's tracking a scent. And if you've ever trained a dog for tracking, you know how difficult it is because they're like squirrel, 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 squirrel. And anything that catches their attention, especially smells, which is what they're supposed to be tracking, will throw them off course. And so in order for the pooch to be able to track in a reliable manner and stay on that track, sometimes for long periods of time, they have to be able to exclude extraneous sources of stimulation that might seem a little bit more desirable than the job that they have been hired to do. All right, I wanted to look at a little bit of EEG, and I hope that Jay will comment on this as well. This is an example of a lateral prefrontal cortex dysregulation. It's a global Laplacian montage. This is a 50-year-old female who presented with MRI findings showing dense white matter damage in the lateral prefrontal cortex. Her symptoms were distractibility, problems with word finding, short-term memory, working memory, and depression. All of the things that we were just talking about as dorsolateral and far lateral problems, obstacles that can happen when the brain isn't firing at the right frequencies. She was forgetting recent events or experiences. And although I think she probably had a stroke or a series of strokes, she may have had them in her sleep, and she may not have known what was going on here. So do you want to pause here and have Jay comment on this? Because we've got...
Jay, do your thing.
Do your thing,
Well,
Jay.
You can see the rhythmic slow wave coming out of the dorsolateral frontal cortex and the anterior temporal region. The delta activity, you can see this is 1 second. So there's maybe 3.5, 4 of them. There's a delta focus, which means there's white matter change in the area. And there's also alpha rhythmicity there. So there's probably some impact on gray matter as well, but it's lateralized. I'm going to clear my bad art. And what you basically see is lateralized to the left. There's none of it on the right side. So this is a focal slow wave, obviously consistent with the MRI findings and all the symptoms that are presenting as well. So you've got a very nice example where the MRI shows the structure, but we show the function within the EEG. And you sometimes have not just the area of the white matter change that's on the MRI, but things that are networked to them. And you can see obviously the slow focus left frontotemporally, directly related to the symptom presentation. This is a nice little example, Mary.
Well, let me, there's a couple more here. Let me show you here.
Oh, this
is another section. It's another screenshot. So this isn't one, it wasn't like a single finding at one point in time, right, Jay?
Yeah, and if you could drag the top one down and superimpose them, you'd see that there's basically the same waveform at the lateral frontal and temporal locations. And unfortunately, with a major structural problem like this, it's hard to bring everything back online without some direct intervention. You don't expect this to, quote, spontaneously recover. The white matter change that's present is very difficult to recover. In fact, until maybe 10, 15 years ago, I used to think that the white matter changes were permanent. That's your wiring. You've got to work with the gray matter. That's neuroplastic, but the white matter is a lot more difficult to change. But, Murray Beauregard at Montreal Neurological published a paper on neurofeedback showing gray matter and white matter change with the training. Yeah, he published a couple of those papers, but it wasn't until I saw the diffusion tensor imaging studies by Dr. Pineda at UC San Diego on autism cases where the DTI looks at their white matter change, and the neurofeedback sculpted the white matter. So the white matter is still plastic. It's just a little harder to get it to change. But neurofeedback is one of the only real reliable ways to get these areas back online. All the talk therapy in the world doesn't necessarily get you to be a better person at word finding. literally training the dorsolateral prefrontal cortex and the anterior temporal area to get rid of that slow focus and to help stabilize it, you can end up seeing these functions come back online. It's
And I've
not
had
just
so many.
it's
Sorry,
not just
Jay.
the slow focus. There's also fast activity in the same area. The beta buzz that you see at F7, that's part of the same problem. The brain is trying to compensate for the slow activity. When the beta spindle kicks in, you can see that the slow content basically ends. The beta spindle that you see there is probably somewhere in the mid-teens, somewhat like an SMR-like frequency or a low frequency of beta. And again, the brain has used that to compensate for the slow activity, kicking the area back into function.
And you see a relatively fast alpha rhythm in the back of the head here, which usually correlates with a higher IQ, normally fast processing speed. So, yeah, well, better declarative and somatic memory as well. So it's a relatively young 50-year-old woman who is very intelligent, very well educated, who's really frustrated because she has the capacity and the history to be able to perform at a very high level, but because of these prefrontal cortical areas of dysregulation, she can't make use of of the right stuff that she's got back here in order to do word finding and working memory, for example. So I have one more example of this, Jay, where, let's see, we see two different areas. One, a very, very long run here of slow activity with a lot of delta, and something similar here. Any more comments, Jay?
No, just more of the same underlying pathology. Again, you can see the faster activity in between and the faster activity kind of trying to stop all the slow activity that's present. Neuromodulation can end up helping in these cases. There are neurofeedback and neuromodulation approaches to end up dealing with the slow activity and reactivating this cortex.
I think Jay's talking about transcranial DC current stimulation as neuromodulation, right, Jay?
Yeah, and there are people that also use TMS, which is awfully expensive by comparison. DC stim device is a couple $100, and you're dealing with the cheaper TMS machines being at 100,000, and the more classic ones at 250,000. So, if you're a grad student on a budget, you probably are going to do DC stim research rather than TMS research because of the cost of the intervention.
I remember one time when I was assisting John Anderson in teaching a qEEG class, Douglas Daly did some presentations, and he brought along a 9-volt battery and some electronic supplies, and he taught everybody how to make their own TDCS device.
Yeah, and the difficulty with homemade devices is that some people will learn how to make a voltage regulated, and others will build a current regulated circuit. Yeah. A current limited circuit keeps you from burning the person's ear or other location when they get a dry contact that passes all the current through one dot. So if you're not current limited, you can end up having voltage limited that ends up burning the skin. I mentioned the do-it-yourself approach to some folks at a workshop of mine. I suggested one point.
Mary Tracy, thank you so much for coming on part 1 of the show. We thank you all for listening to NeuroNoodle's Neurofeedback and Neuropsychology podcast. We'd like to thank our Patreon business supporters and our show sponsors. Mary Tracy's NeuroTraining Strategies offers a higher standard of EEG, qEEG education to EEG clinicians, technicians, and neurofeedback practitioners with convenient online BCIA and qEEG certified didactic courses. Register now at eegstrategies.com/course-neuro. Check out the 6th Annual Super Brain Summit this April 8th at Bradley University, featuring Dr. Bruce Wexler, psychiatrist at Yale Medical School. He'll discuss neurotherapeutics and how we can regulate the brain with computers. Register at bradley.edu/superbrainsummit. Do you have an idea for a topic or a guest? Email Pete at neuronoodle.com or leave a voicemail in the podcast link below. Please give us 5 stars on Apple Podcasts and subscribe to our YouTube channel. And hey, if you really, really, really like us, you can always buy us a coffee on Patreon/NeuroNoodle. We love our Patreon peeps, don't we, Jay?
Absolutely, Pete. They get great coverage on this show, don't they?
Oh my, just ask Mary. Cue the
I'm getting
music.
it. I'm getting it. Thank you. I love it.
You're feeling the love. Well,
I'm feeling
we'll cut
the
that out.
love, baby.
We don't